Today, on how it's made. Kitchen accessories. Central vacuums. Paper mache animals. And hydraulic cylinders. When it comes to kitchen accessories, many cooks choose to forego metal, plastic, and silicone in favor of a more classic material, wood. Wood is not only elegant, it's lightweight and very durable, and its look fits in with traditional, contemporary, or modern kitchen decor. Rolling pins, meat mallets, cutting boards, trivets are some of the many items this Czech company makes out of beech, a hard and durable type of wood. The first step is to dry out the logs. This prevents the wood from expanding and contracting with humidity changes and eventually cracking. The factory air dries the logs outdoors for about 7 months, then heat dries them in a kiln for 3 to 4 weeks. When the moisture level is down to between 8 and 10%, the wood is ready. Each log first goes through a large automated hacksaw. It slices vertically, cutting the log into several pieces of the specific thickness required for the kitchen accessory in production. Next, a dimensioning saw cuts the pieces to the required length. The final cut saws the pieces to the required width. To make a cutting board, they run one edge of the cut pieces through a gluing machine. Then they assemble the pieces edge to edge in a press. The number of pieces they put together depends on the size of the cutting board they're making. After an hour clamped under pressure, the pieces bond into a large panel. Workers then cut the panel into the smaller pieces, each of which will become a cutting board. A computer-guided milling machine cuts the shape of the cutting board, which in this case is a model with a recessed middle designed to catch crumbs. They submerge the cutting boards in vegetable oil, then let them air dry for a day. Oiling nourishes the wood, which prevents it from drying out. The oil also enhances the color and brings out the beauty of the wood grain. To make rolling pins, workers feed the cut wood through a planer. It finalizes the dimensions to 7 by 7 centimeters wide by 26 centimeters long. Then they mount several pieces at a time onto a machine which has multiple lathes. As each lathe spins, over the course of about 30 seconds, successive tools turn the wood to a cylindrical shape and sand the surface. One cylinder at a time, workers drill a 12mm hole right through the middle. Meanwhile, a small lathe turns 3 by 10.6 centimeter blocks of wood into rolling pin handles. Workers saw off excess wood at the outer end of the handle and sand the area flat. The finished handle goes into a revolving barrel of varnish for about an hour. All the parts are now ready and assembly can begin. After giving the ends a quick sanding, they hammer a nylon ring into the hole on each side of the pin. The ring diameter is slightly larger than that of the hole, so it locks in. Next, they insert a zinc-coated steel rod all the way through, position the rolling pin in a press, fit a handle on one protruding end of the rod, then a second handle onto the other end. They activate the press, which forces the handles all the way onto the rod. The pin rolls smoothly, thanks to the nylon rings. These kitchen accessories showcase the natural beauty of wood. Wood that's FSC certified, meaning it comes from a forest that's managed according to standards of environmental protection. A central vacuum doesn't have to be pulled or carried from room to room and up and down stairs. Its power unit, containing the motor and dirt receptacle, is mounted on a wall, usually in the basement or garage. This stationary unit connects to plastic ducts that run inside the walls to inlets in different parts of the home. You plug the attachment hose into the nearest inlet, and the central power unit suctions the debris through the wall ducts. Being stationary, weight isn't an issue. Therefore, central vacuum motors are larger and more powerful than those in portable vacuum cleaners. The factory makes the main body of the power unit out of a steel sheet about 1 millimeter thick. A press punches out the openings required for the various components. A forming roller rounds the sheet into the unit's circular shape. They close the circle by tack welding a few key spots. Then they weld the entire length. This continuous seam makes the unit airtight for optimal suction and to prevent the collected dirt from escaping. They use the same material and technique to form the sides of the power unit's large dirt receptacle. Then a hydraulic press rolls the rim at the top, making the receptacle safe for the user to remove, empty, then put back in place. They make a rim on the bottom edge as well, sealing it over the bottom plate of the dirt receptacle. Then they put the power unit's main body on a hydraulic press and shape a rim that connects to the dirt receptacle. Next, they make a support for the motor and tack weld a mesh basket under it. The basket supports the vacuum cleaner's filter. The power unit's main body goes on top of the dirt receptacle. The motor support and filtration basket fit inside, and a cover goes on top. Now the unit gets a coat of high-quality epoxy paint. The application system is electrostatic, meaning it charges the unit with a negative current and the powder paint particles with a positive one. This magnetically draws the particles onto the unit in an even layer. Then 45 minutes in an oven bakes it on for extra durability. They seal the connection between the dirt receptacle and the power unit main body. This must be airtight for 2 reasons: to prevent air from leaking through, which would lessen suction power, and to prevent collected dust from escaping. Next, they line the main body's motor compartment with soundproofing foam. An adhesive backing holds it against the compartment walls, and dabs of liquid adhesive secure the corners. They install a filter on the outside to capture carbon dust. Carbon dust is a fine black dust which electrical motors emit. Now they apply decals bearing the series name and model number. They use a laser level to position them perfectly straight in just the right spot. Back to the motor compartment now. The electric motor sits on this rubber foam gasket and rubber legs, both of which absorb vibration. They also prevent metal-to-metal contact between the motor and body, the secret to the vacuum's quiet operation. Whereas portable vacuum cleaners have a lightweight motor with a single fan, this motor is a large, heavy-duty, long-life steel motor with 3 fans. The electronic components go into the neighboring compartment. Then workers use a variety of equipment to test suction, voltage, and other specifications. They connect an LCD display on the outside, cap the compartments with a motor cooling insulated disc, then the unit's cover. The factory's lab selects a certain percentage of units at random for quality control testing. During operation, the LCD screens on both the power unit and hose handle display the power level. They also indicate when the unit needs technical maintenance, when to empty the dirt receptacle, and when to remove and wash the filters. They're a bold option for people looking to go a bit wild with their home decor. Large, colorful animals made of paper mache. Inanimate, exotic pets that make quite the conversation piece. Sold in galleries or upscale design boutiques, each creature is a unique work painted by an artist. These large-scale paper mache animals are handcrafted by artisans in Tonala, Mexico, a town renowned for colorful decorative arts. They cast the animal's shape in plaster and fiberglass molds. There's a 2-part mold for each of the animal's main body parts. The artisans dampen pieces of recycled cardboard, then glue them onto the walls of the mold cavity. They continue until they fully line the cavity 5 layers thick, 3 layers if it's a small-sized animal. Then they close the mold and set it aside to dry, which, depending on the size, takes from 3 to 6 days. Then they open the mold and extract what is now a hollow cardboard shell of the body part. They assemble the animal by adhering all the body part shells, reinforcing the joints with strips of newspaper. Then they paper over the entire surface to even it out. The paper dries in 3 to 12 hours, depending on the size of the animal. Next, they mix together talc, water, glue, and wet cardboard. This recipe produces a thick adhesive paste, which they spread evenly over the entire animal. The paste takes about 40 minutes to dry and harden. Then they apply a second coat. When that dries, they water down the paste to a thin, runny consistency and apply a third coat. Once that dries, they send the animal to the detailing department. There, using the thick paste, artists sculpt and apply raised body and facial features. Once the paste detailing dries, they sand the entire animal to prep for painting. In the art department, they first apply a primer coat, white or beige. This seals the surface. Once the primer is dry, they paint the animal's background color. Now the true artistry begins. Using watercolors, artists make the animals come alive with expressive eyes and fanciful features. No stencils or predetermined designs. The artists follow their imagination and create a unique work of art. The last step? 4 coats of transparent lacquer in either a high gloss or matte finish. The lacquer dries hard as a rock, forming an impenetrable protective layer over the paint. The paper mache surface is now durable and moisture resistant. These handcrafted animals are sought after by collectors around the world, which might explain why it's a jungle out there. When the pressure is on, that's when a lot of machines really perform. We're talking about the kind of pressure that comes from hydraulic fluid as it's pumped through cylinders. From crane claws to snow plows to a lot of manufacturing equipment, hydraulic cylinders are truly a driving force in the world. This is fluid power in action. Pressurized fluid pumped into cylinders does all the heavy work, making this forklift actually lift. Production begins with the cylinder barrel. A bandsaw cuts steel tubing to the correct length. Then computerized tools carve a solid cylinder to transform it into the piston rod. It's this rod that will be moved by hydraulic pressure to transfer force to a machine like the forklift. The tools cut threads in one end and also carve various diameters. This will have a cushioning effect as the machine the cylinder powers cycles down. The other end of the rod will be attached to the piston, which is now taking shape, as a special tool bores through the center to create a threaded hole. Using a special gauge, a worker measures the hole's dimensions to confirm the piston rod will fit into it exactly. Another computerized cutter then carves grooves on the outside wall of the piston. With the piston now complete, they install a web of sealer rings on both it and the cylinder head, which has been machined in a similar fashion. These sealers will prevent leaking of the pressurized fluids as the piston rod moves through the center holes of these parts. This blue sealer will also act as a wiper, removing dirt from the piston rod and keeping contaminants out of the cylinder. This O-ring installed on the outside of the cylinder head will stop fluid leakage between it and the cylinder barrel. With the sealers installed, a worker now lubricates the mouth of the cylinder head. This allows for a smooth installation of the part to one end of the piston rod. He then slides the piston onto the other end of the rod and secures it with a nut. He tightens the nut to the rod using an impact gun. Production now returns to the cylinder barrel as a robot welds a cap onto it. The open fitting adjacent to it was installed earlier to attach the hose that delivers the fluids. The worker now clamps the cylinder barrel in a device to stabilize it. He lubricates the threaded open end so he can easily slide a metal sleeve into it. This sleeve prevents snags, so those critical sealer rings remain intact as he now inserts the piston rod assembly into the barrel. Once the piston is safely in the barrel, he removes the sleeve. He then shoves the rod further into the barrel and screws the cylinder head to the threaded lip. Using a spanner wrench, he tightens the assembly to the required torque. He dabs adhesive onto a screw and inserts the screw in the cylinder head. The adhesive dries and expands to lock the screw tightly in place. They now etch the client name, part number, and other information onto the assembled cylinder using a computerized engraving tool. This cylinder is now ready for fluid, hydraulic-grade oil specially formulated to operate under pressure. The technician attaches hoses to the cylinder to fill it with pressurized oil. As the pressure builds at one end, the piston rod extends. He then supplies fluid to the other end and the rod retracts. He runs a finger around the fittings and sealers to check for leaks. He gives this hydraulic cylinder the all clear. After a good wash, a worker spray paints the hydraulic cylinders to protect the metal against rust. Now complete, these hydraulic cylinders are ready to leave the factory. They'll soon be under a lot of pressure to keep machines and mechanisms operating, but it's the kind of pressure they've been made for.